All right, here we go. All right, I think this is the wrong slide. This is actually DOS 311 running MS-DOS in the cloud, so hopefully you all are in the right room for that. But all right, tough audience for a Wednesday. Joking, no. This is scaling on AWS for your first 10 million users. Thank you for coming here. Really appreciate you trekking out here to the furthest away venue for this week, and hope that you're having a great week so far at reInvent. My name is Chris Munns. I'm currently the tech lead for the startup solution architecture org here at AWS. I'm joined here by Carl Suarez, who will be speaking here in a little bit. But again, we really appreciate you coming out for this talk. Now, this is actually a revisit of a talk that we've done here at AWS for a number of years now. Some of you might have seen slides from this talk over the years as it's been played out. It's actually been delivered at every reInvent since 2013. And I actually first created this deck for a VC event back in 2013. And what I noticed in coming into this year's reInvent is that we haven't really changed the story that much. The original deck was very much focused on taking an application from essentially day one, user one, and then building it forward to where you could hypothetically support 10 million users. And I like to say that we're thinking of like 10 million active users in a month. But the deck had gotten a little stale. It was still a little too EC2 focused. And so what we've done here is we've completely re-envisioned this deck, kind of given based on what we see and hear from customers today. And Carol and I both, again, work with startups across the Americas at all different sizes and scales. So what do we mean we're talking about an app? So we are going to be talking about kind of a prototypical, three-tier app, if you will, something that's very common to see both in startups but also in enterprise organizations, where there's some sort of client, perhaps a web application or a mobile application. You've got some sort of business backend, like your logic that you have to execute and run, and then you've got a data store to store, your business or customer information. Now, again, many of you are building apps that won't look necessarily like that, but hopefully what you'll get from this talk are repeatable patterns and methods that you can use for scaling the tiers that exist inside of your applications. And again, what we're going to give today here is a lot of very kind of general guidance. I don't know necessarily if I would say that it fits an 80-20 rule, but it does fit a lot of the use cases and models that we see with customers today. So it's very unlikely that your first architecture is the one that you keep for forever inside of a business. But I think that this does establish some pretty good basic patterns. And the other thing I'll say, and this is probably pretty obvious, is that iterating in an architecture like this, which we're going to iterate through this architecture, is kind of a cycle or a flywheel of build, measure, learn, build, measure, learn. And so we'll talk about some of the tools and techniques and how to think about that as well. But let's get started. So let's again say that you're building a new application, again, whether this is an entire business or this is something inside of a larger company. It's day one, it's user one, and so we want to figure out where we're going to start and where we're going to go. Now, in the past, we would have typically seen, and we obviously still see this today, people starting on EC2. So you'd have an EC2 instance, you would have probably an elastic IP attached to that, you would point DNS at that, and so it's very common to have this starting point of running your entire application stack on this. And actually in the startup space, it's really common for us to see young tech teams start with this model of a single host and kind of building out off of there. So you'd have your presentation layer, your business layer, your data layer, kind of all running on that single host. But again, what we see is this kind of going out of style and not being as common in the world today. So what really has changed? The biggest thing I would say that's changed since the beginning of when we delivered this deck starting in 2013 to now is over the last 5 years, there's been such a drastic shift in how the front ends of many applications are built. And a lot of this is piggybacking on top of the popularity of major frameworks that we see today, like React and Vue and Angular and kind of the large industry of these that exist. And there's many derivatives of these, things that are built on top of them. And I included here some data that we got from Stack Overflow's developer survey. And I think they run one of the richest surveys every year of technology data and polling from developers. So I'd encourage you to check it out. But what you can see here kind of is the percentage of the people who were polled in this who are using these different technologies. So again, it's a lot of developers that are building with Node.js, with React, and with some of the rest of these. So these frameworks, though, kind of align and enable with a different way of thinking about building applications, as well as how you'd host these applications. Now, you could definitely take a React app, throw it on an EC2 instance, run Nginx, serve out that static content. A couple of years ago, we would have said to you, hey, you know what, you could put all that static content in S3, throw CloudFront in front of it, and serve it from there, and you still could do that as well. But the challenge is that there's really no developer experience benefits that you get from doing that. So generally speaking, what we're seeing is kind of a really huge emergence of purpose-built tools for hosting front ends. So I'll talk a little bit here about AWS Amplify Hosting, which is our product. We also see companies like Netlify and Vercel being incredibly popular and growing rapidly. And again, there's a lot of companies that have built front-end hosting tools. So why are they growing or succeeding? Well, what I would say is that, one, they fit this mantra of, you can think of them effectively as serverless-ish, right? You're not running infrastructure. You're not thinking about the underlying hosts. You're not doing patch management. You're not doing, operating system tuning. Pretty much all of these have a model where you throw code at them and they build and scale. And so the developer experience ends up being much better aligned because of deeper integrations and because of the models that you see. So all of this ends up being kind of really powerful. And so what you start off with pretty much day one is at least a two-tier architecture where you have your front end hosted on something purpose-built, and then we'll kind of break down here into the back end here shortly. So again, just a couple bits here about Amplify Hosting for those of you who maybe haven't seen it before. It's a really pretty simple service. You can connect a code repository up to it. You can configure some build settings for your framework of choice, again, whatever you're building with. And many of them will have different tips and tricks and things that you might want to do, including even doing things like unit testing as part of this. And then it deploys your application. And so from there, that's kind of the extent of the work that you need to do in configuring and running that front end that can scale. Now, behind the scenes, Amplify Hosting is built on top of CloudFront and a number of other components here at AWS. And again, I was talking about that kind of aligned developer experience that we see customers looking for. So with Amplify Hosting, you get access to things like feature branch deployments, access to being able to do things with user security, being able to align with setting up custom domains and atomic deployments. And again, you can't really do those same things if you were throwing a React app into S3. And if you were doing it in raw EC2, that would be a lot more work for you. So again, the emergence of purpose-built front-end hosting, really, really common. And I would say a good number of the percent of startups that we engage with in the early days do start with that as one of their first architectural components. So what about the back end? So as probably all of you know here, we have a number of different options for compute here at AWS. I think it was during Adam's keynote the other day, he said that we now have over 600 instance types, which I joined AWS in 2011, and we had many, 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 many fewer than 600. So it's kind of a wild number. But there's a lot you could do, obviously, with EC2 in the different ways and sizes and shapes of instances that we have. We then have the container ecosystem, so Amazon ECS, EKS, and AWS Fargate. And then we have Lambda. And I spent about 5 years leading developer advocacy for serverless here at AWS, and so deeply, deeply familiar with Lambda. Some exciting news there this week as well. Now, when it comes to evaluating the compute options that you have, again, you can do things with just raw EC2. A lot of people do. But the downsides to that are the things that become really apparent, right? If you're building with EC2, then you're having to think about things like failover and redundancy. You're having to think about how if you were running, say, your app tier and your database tier on the same host, how are you kind of thinking about sharing the resources inside of those? And then effectively, you could end up finding yourself constrained within the technology that you have based on that choice. Also kind of eventually leads you to this model of, too many eggs in one basket, right? Can your database overwhelm your backend service? Can your backend service overwhelm your database? So again, the downsides of this become apparent pretty quickly. And this doesn't end up giving you, again, good benefits from a developer experience or even from an operations perspective. And I'm a huge fan of really doing less in the cloud via not having to build and manage all these building blocks myself. So the guidance that we've had now for a number of years is to start with a more managed compute offering. And then guidance that goes back even further than our managed compute offerings is to use a managed database offering. And so again, instead of growing into this, we see more companies starting right off day one thinking this way. So when we come to thinking about the managed compute offerings, and there's obviously a lot of talks about this week that you can get a lot of depth on each of these services, you could think of it as kind of a spectrum that starts at the top of being more opinionated, down at the bottom gets to EC2 where you would take on all of the activities that you would want. And if you look over all the way in the top right-hand corner for y'all next to Lambda here, you kind of see that what you would manage with Lambda is pretty much just your code. Or you're not thinking of any of the underlying infrastructure. And then as we go down here to Fargate, you get a little bit more thinking about data source integrations, like how does your Fargate application get called or invoked. Having to think some more about like security and networking and stuff that you wouldn't have to do with Lambda. But again, kind of above that midpoint, I say is the best place to start exploring where you want to host your application. Because as you go lower down, then you are taking on more responsibility. So that's one aspect of hosting your backend application. The second is how you actually think about exposing it. So again, in the original model with EC2, we'd be thinking about things like elastic IP addresses. Even longer back ago in history when we had EC2 Classic, you would have kind of all of your hosts possibly open on the internet. But when we're thinking about a modern backend today, pretty much every customer that we talk to is building an API. Now, when it comes to hosting that API, there's different ways of thinking about that here. And so we've got a couple of options today that we see pretty common. Amazon API Gateway, part of the overall serverless family. It's been around now for about 6 or 7 years, purpose-built for RESTful APIs. Application Load Balancer, which acts effectively a bit more as kind of a layer 7 proxy, has some good capabilities for route mapping and stuff, but not all the bells and whistles that API Gateway has. And then we have AWS App Sync, which is more for hosting GraphQL-based APIs. And I would say it's bordering almost these days on 50-50 for where we see startups starting with GraphQL versus sticking with REST-based APIs. And so the popularity of GraphQL has really mirrored the popularity of these modern frameworks. A lot of the how-tos that you'll see with things like React and Vue will actually assume that you're going to build with GraphQL behind the scenes. So again, both are pretty popular options. Now, in thinking about all of this, I might have to think about, okay, which compute option and which way of presenting my application and having to glue all those together. But instead, what I would like to do is thinking about, again, how can I do less and less work? So AWS App Runner is part of our overall kind of serverless container ecosystem. It's been out for a little over a year and change now. And what App Runner does is it basically puts together for us a full stack of resources. It's going to give us a load balancer. It's going to give us ECS with Fargate. It's going to give us auto scaling. It's going to give us Elastic Container Repository, all built together with the ability for us to build and deploy our code with a whole bunch of cool bells and whistles. And we could do a whole talk on App Runner today. I wish I could get deeper into it in this talk, but there is a couple of great talks this week on App Runner. And again, what we get with this is two kind of options for deploying our application. We can deploy an entire container image, or you can use the managed runtimes, very similar to what we have in Lambda today. So two different options for how you think about deploying your code, what you're deploying inside of it. But effectively, App Runner exposes an application in one of two ways, either as an API or just as an open web server. So if we think about how that fits in now here, again, with Amplify Hosting, both of these options give us pretty much the exact same types of benefits. Not managing any infrastructure, whether it be EC2 or container-based or anything else that I'm thinking about raw resources. I have options for scale and performance built in, which again, we'll get into depth on this here today. I have integrations with my frameworks. So whether I'm talking about using managed runtimes and Fargate or some of the pre-built capabilities that Amplify has for different front-end frameworks, I've got some benefits there. And then again, from a developer experience perspective, both of these products give me the ability to connect a code repository, configure my build, deploy, and go. And so again, reducing a lot of the burden and friction in getting started. So the next thing we'd have to think about then here is our database. And pretty much when we start talking with companies about databases, the first thing that comes up is, what kind of data store am I going to use? Am I going to go relational or non-relational? And nowadays we have a managed offering for almost any kind of database that you could think of. Now, the guidance that I'm going to share here does not win me favors with some of my peers here at AWS, but my guidance is typically to start with SQL-based databases. I'm waiting for boos or tomatoes to be thrown at me. Okay, I don't see anything coming at me just yet here, so that's good. But this is controversial in some circles here, and I love me some DynamoDB. I'm good friends with some of the heroes that we have in that space here at AWS. A lot of folks who go through formal education, computer science degrees, end up spending a huge bit of time learning about relational databases, relational database structure and history and all of that. And so again, what you end up with is just kind of less friction in the macro sense getting started with relational databases. Now, there are going to be people who are going to find lots of different reasons why a relational database may not work. And one of the biggest ones that I'll always hear people say are things like, oh, well, I'm going to have way too much data for a relational database. And so that ends up being one of those places where people kind of right away are like, no, 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 we're going to be scaling so far, so fast. There's no way this is ever going to work. We need to preemptively optimize today for it. Now, I like to quantify what massive scale means pretty clearly, right? We're talking about, are you going to have terabytes of user data in your first year? And again, we're talking about building an architecture that we know we're going to need to optimize over time. So unless you know that within that first year, within those first couple of thousands or tens of thousands of customers, are you really going to have that much data? Or are you going to have an incredibly data-intensive workload? And again, these things typically stick out and look like needles in a haystack effectively. So why else might you really truly need a non-relational database? And I'm saying NoSQL here, but I also mean things like document stores, graph databases, time series databases. Again, there's about half a dozen plus different types of databases that exist today. Things like super low latency based applications. Now to clarify, most human interacting apps do not quantify as that. When I'm talking about super low latency, I'm talking about things like high frequency trading. That's a very specific type of a workload, not something that most of us ever will deal with in our careers. Things like metadata-driven sets or truly non-relational, non-structured data sets. Again, not something that shows up incredibly common. So again, this isn't most of you, and so again, the guidance that I stick with is to start with SQL or relational-based databases. Now, hopefully at this point, you're familiar with Amazon Aurora. Amazon Aurora has been out for a number of years now. It is our fastest growing service that we've ever had here at AWS, which is interesting because it displaced Redshift, which was the fastest growing service before that, which displaced DynamoDB, which was the fastest service before that. And so it's interesting to see how we've gone with database services being some of the biggest things that we have at AWS from an adoption perspective. And again, what Aurora gives you is a whole bunch of capabilities. I'm not going to get into all of those today because I'm actually going to skip to where I think some of the most exciting bits of Aurora are today, which is Aurora Serverless v2. Now, we first announced v1 a number of years ago. A number of you might have tested it, kicked the tires on it. It had some issues, it had some isms, and so the team rethought it completely and launched v2 last year. Now, v2 is really exciting. It's got, again, a number of really great capabilities around how it operates on demand, how it scales, how you can continue to kind of scale it over time. And again, we'll go into a bunch of depth on this soon. So combining all of these together here, Amplify Hosting, App Runner, and the Aurora Serverless v2, we actually start with a stack that's going to take us really far without us necessarily having to think about a whole lot of effort up front. Again, I'm not managing any infrastructure here, so I'm not dealing with any instances. I'm not dealing with any containers. I'm not thinking about any container orchestration. I'm not patching any operating systems. I might not even be thinking about my own runtime libraries beyond what my application actually needs. Each of these have high availability and multi-AZ built in. Each of these has a breadth of security options for controlling access, both from the consumer side, but also from the operator and developer side. And again, with the ability that they have to scale means that as your business grows, you can go from kind of a low fixed initial cost up to paying for what you need to based on business value. So again, very early on here, I'm kind of starting with a really powerful stack. So from here we can go pretty far, right? Definitely into the hundreds of users, definitely into the thousands of users, definitely into the tens of thousands of users. And then at some point here, we might start to run into some problems and need to think a little differently. So I'm going to hand this over to Carol now to talk to you about how we might have to move forward.
Awesome. Thanks, Chris. So congratulations. You made it to 10,000 users. That's absolutely amazing. But this is the part where you start running into some of those common architectural challenges, whether some of those products that you're currently using, you might see some limitations. You may start to see poor performance in parts of your application. So for example, your data set that you had in that database over a year has immensely grown, and that query you wrote on day one is perhaps not the most optimized query that you should be using today. So we're going to break down this architecture into three parts: the front end, the back end, and the data storage. and really think about how do we scale and optimize performance along the way. So we're going to start with the front end, probably the easiest part of this architecture. So as Chris mentioned earlier, we're going to be using AWS Amplify, which under the layers of Amplify uses CloudFront. And CloudFront, if you're not familiar with it, is our content delivery network. And it's built on top of over 400 points of presence globally. So as you're using CloudFront, you don't have to think about managing infrastructure. What you have to think about, in this case, is your application. How do you make sure that your application is the most performant? And that comes down to tuning your front-end code, perhaps reducing the number of backend calls that you make. So you want to make sure that you bring as much content to the front as you can, so you're caching that closer to your end user. And then all those images, JavaScript, CSS, keep that cache closer to your end user. In terms of CloudFront itself, you can also control access to your content. You can decide what kind of freshness or expiration should I allow for my content. And then you can also manage your cache hit ratio. So that means how much of your content is being delivered via the cache, CloudFront, or hitting the origin server. So that seems pretty straightforward and pretty easy. But before we go too much further, there's something really important that we need to think about. One of your end users might say, oops, sorry. They might be saying, hey, your application is loading really, really slowly. And you might be thinking, OK, maybe I should make some modifications. Where should I start? But at the end of the day, we should really be trying to make data-driven decisions. We want to be only tuning what we're measuring and not just making changes here and there. So where we need to start looking is in observability tools and tooling to really capture those metrics, logs, and start to think about even event-driven responses to thresholds being met. So two of the most common services that you may be looking at are Amazon CloudWatch and AWS X-Ray, both built natively into all the services that we mentioned earlier. So with Amazon CloudWatch, we have customers building their own custom dashboards based on the metrics that they're receiving from their application. Perhaps you're creating alarms so that at 80% of a threshold that you reach, an alarm is being sent to your email, and you know that something's happening. And yes, Amazon CloudWatch does also deliver rum. And no, that's not the rum that we'd like to drink, but real user monitoring. So in real time, as your users are accessing your application, you can actually see what's the session state, what are some errors that they are maybe running into. On the other side, if you want a holistic picture, you can actually use AWS X-Ray. And what AWS X-Ray is tracing from your end-to-end application, going from your load balancer to your compute to your database. You can really see where performance issues might be happening and get a more holistic view of your application. So that's great. We have all our metrics here, but what more could we be doing? Over a couple of years from now, we were looking at Amazon.com metrics. We're looking at how do we best help our customers. And we decided that a lot of these recommendations can be provided based on using machine learning. So really recently, AWS, we came out with a few machine learning services that really help provide recommendations. So in terms of your application, Amazon DevOps Guru will take metrics, whether it's like latency, HTTP requests, CPU utilization, and help you find the most common bottlenecks and issues and actually provide recommendations on what you could do to improve those bottlenecks. On the other side, which is your application code side, sometimes application code can be not as efficient as you want it to be, but you're not sure where to start. So what Amazon Code Guru does is that it takes your code, analyzes it, and will actually also provide recommendations on how to perhaps remove a certain line of code that is causing slowdowns in your application. So with all those tools in mind, you can start looking at where are my slowest database queries? Is it, what are the top 10 that I can start tuning for? Where are my slow API requests originating from? Why am I really getting these failures due to increased traffic? Is it from my database layer? Is it from my front end? Where is it coming from? And at the end of the day, really getting down to how is my service operating between all the parts. So now that you're able to visualize and see and quantify what is happening with your application, we can start thinking about how do I actually scale this and what is the best way to scale. So let's dive a little deeper into the data tier as to what Chris was mentioning, which is Aurora. So looking at Aurora Serverless v2, one of the ways that you can actually scale and not even have to think about it, which is amazing, is that as you get more requests and more traffic, the underlying instance can grow and can scale up or down as needed. Aurora will actually manage the connections, so as it grows, you're never going to have a dropped connection, and as it shrinks down, not a problem at all. So CPU, memory, no problem, and it's all managed by Aurora Serverless. If you're finding that you have really read-heavy traffic, the pattern that we do recommend is to add read replicas. So you might start with 1 or 2, 3 read replicas across the AZs, and all the configurations of these read replicas will be inherited from the cluster. So in case of a database failure, you can actually promote one of those read replicas to become your primary endpoint. And so yes, that helps in terms of read-heavy traffic, CPU utilization, memory, but one of the most common tools that we also see customers using is a proxy. So as you may have already figured out in the past, your connections to your database and all those open connections sometimes causes a lot of exhaustion on your database. Your CPU memory really gets used up. So one of the recommendations that we do have is to implement an RDS Proxy. And this can be used with Aurora Serverless provision in a mixed configuration as well. And this will really help you manage your entire cluster of Aurora. So putting this all together, what does this look like, expanding on the architecture? So behind App Runner, we actually have RDS Proxy as kind of the gateway to your database, and then you're going to have these read replicas across multiple availability zones for high availability. And as time goes on, your traffic increases, maybe you're at 50,000 users, 70,000 users, you can continue to scale by adding read replicas and increasing those sizes of your nodes in the cluster. So seems pretty simple, right? But going forward from your infrastructure, there's something that you have to remember, that those queries that I mentioned that you wrote on day 1 might not be as efficient as day 100, day 10,000, when you've been using this application for a long time and the traffic is really increased. So one of the patterns that you should start looking at is actually a caching pattern. And one of the services that we recommend to use is ElastiCache. Maybe some of you have used in the past, Memcached and Redis, very industry standard. And with Amazon ElastiCache, it's another managed service. So you're not having to worry about having to manage the underlying host. You can scale from 1 to many nodes. It can replace any failed instances. And at the end of the day, just like Aurora, you also have a multi-AZ deployment available for you. So what that looks like at the end of the day is that you're bringing all of those queries that might be commonly requested and caching the responses to that instead of constantly having your traffic go directly to the RDS proxy or to your database itself. So the 3 main things we want to think about when we're scaling our data tier is 1, increasing that size of the instance. 2, adding any read replicas and a proxy to really help with that read-heavy traffic. And then 3, using caches as much as you can to remove queries from even being made. And yes, there might be some engineering effort that is put into place as you add it on a cache, but it can really make a significant improvement on your application and your end user experience. So finally diving into the backend tier, we're going to look a little bit deeper into what can we do with App Runner. So App Runner, under the hood, has 3 main components. You have the public endpoint, which is your internet-facing network load balancer, which will then send requests to this L7 request router that will process all of those web or API requests. At the back end, you do have your ECS Fargate tasks, and all of these are essentially managed for you. You don't need to worry about them at all. So with App Runner, the unit of compute is Fargate at the end of the day and Fargate tasks, but it refers to them as instances. And similar to your database, the first thing that you can really do is scale the number of instances that you have, or scale the size of instances. So instances here have a fixed CPU. As you can see, you have 1 vCPU, 2 vCPU, and the memory as like 2, 3, 4, and 4. And right now, they're configured to have a maximum concurrency of about 200 requests per instance. And you can see that there is a limit of 25 number of instances per service. So you can start to see where we're starting to kind of slowly reach our limits depending on how many requests you're getting. So at the end of the day, the current limit you're going to hit is about 5,000 concurrent requests per App Runner service. So what you can do is that what happens by more and more requests happening is that with App Runner, it's going to scale the number of instances it's running in the backend. And then these all get added to your L7 router transparently. If traffic decreases, then instances will move to an idle state. You can specify the number of instances that you want to scale to, so you can have a minimum and a maximum to make sure that you are as cost efficient as possible. But App Runner will actually scale down to a minimum of 1 instance, so you never have to deal with a cold start when traffic does return. So at the end of the day, when you're scaling the backend tier, you're going to hit about 5,000 concurrent requests. That's going to give you at least 2 requests per second, and that's approximately 150 requests per minute. So if your requests are faster, you can even do more per second. And this is really where you think about how your application performance tuning is key. Start reducing your calls to your databases and using your caches, and really tweaking and changing that code so that it's optimized for performance. You want to make sure that you're efficiently using caching so that you're not running into any other bottlenecks or problems. So that will probably bring you to over 100,000 users, and maybe that will bring you to 1 million users. And I'm going to bring Chris back onto the stage, actually, and talk about what comes next.
Thanks, Carol. All right. Is that, my mic's good? Cool. All right. So Carol covered here quite a bit, right? We talked a bit about how, one, with Amplify Hosting, scale is kind of built in. We talked to the Amplify team, and we said, practically, have we seen customers hit a limit? And they said that no, it's built for scale. And so the limit basically is the entirety of the capacity of CloudFront, which continues to grow week by week, month by month. We talked to the Aurora Serverless team, and we said, where's the practical kind of scale out point with them? Now, with, again, Aurora, you get up to 15 replicas, I believe that it is, and they can be quite large. So some of our largest R family instances that are very heavy on memory versus CPU. And so again, depending on your database workload, you really are talking about a considerable amount of database capacity behind the scenes. And then Carol talked a little bit about how with App Runner instances, today they can be configured for a maximum of 200 connections per instance. You could today have up to 25 instances per application. And so it actually kind of becomes the first limit that you'd have to think about running into. Talked to that team, they said that they are looking to adjust this in 2023. They're also looking for feedback on the instance sizes. So if you felt like you needed more CPU or more memory, that team's definitely looking for that feedback. Feel free to share it here at the expo this week, or to reach out via account managers that you have. So given all of this, once we start talking about getting into the now millions of customers effectively, again, depending on what your workflow is and what you're doing, we start to see kind of the next level of breakdown of where you have to think differently about how your application is architected and how you'd solve some of these future scaling problems. And it starts to get to be kind of where, again, some of these services do tap out. We also typically will have other things that will happen, right? As your business is growing, as the features and functionality of your application continue to grow and change, you start to find that continuing to keep all of this in potentially a single application becomes a lot more complex. Again, on the database side of things, we talked about really scaling the reads quite heavily, and scaling the writes happens inside pretty much a single node that is your write master. At some point, you could begin to overwhelm that, or just find that kind of the contention for the underlying resource of the database becomes problematic between too many different use cases. So this is where we typically start to see customers really kind of dive into the concepts of a service-oriented architecture or microservices-based architecture. I won't attempt to define one over the other, but breaking apart the application. Now, this is a complex topic. We can't understate that enough. We work with companies of all shapes and sizes, and I've worked with large enterprises. on down through some very early startups about this aspect of refactoring. And there's really not a clear playbook that happens. There are a number of strategies that are out there, though, that you could think of. One is operating by looking at effectively what's called the data domain of the data and of your application that you have. So can you find effectively areas of data structure in your database and in how your application accesses it that you can kind of think of boxing up and separating out. Similarly, you can look at business functions, right? So are there things that maybe users need versus admins need versus data warehouse needs versus supply chain or something, and figuring out how to break that out of the application as well. Now, this is also a good time where it may make sense to look at other more purpose-built tools for the situation in question, right? Evaluating different compute options, evaluating different data stores. And the last thing here that we have to think about is how we're going to glue all this together. So are we going to build huge collections of API-driven services, or do we find other ways for things to communicate? Now, on the database side, kind of what I think is like the easiest route to take as a first step is what's called database federation. So this is taking our kind of single monolithic database structure and breaking it out based on use case into other clusters. At which point then it becomes really easy to kind of rinse and repeat the guidance that Carol just shared, right? We can scale up the nodes based on CPU and memory. We could add more nodes as read replicas. We can add RDS Proxy to do things like reduce contention on the connections that we're having. We can make use of Elasticache to cache queries. And so this becomes a nice, good strategy to then take that initial database and start carving out parts of it, again, ideally without having to do too much re-architecture of your actual application itself. What's great about this is it can really delay having to do a much stronger rewrite or a much greater re-architecture onto a different technology. And so again, with SQL-based databases, as you see here, these patterns become really easy to kind of replicate and stamp out again over time. Now, you might at some point reach the point where you do need to think about a more purpose-built database. Again, based on your needs, that could be a key value store like DynamoDB. It could be a document store. It could be a graph-based database. It could be a time series database. Lots of different ways to think about that. That is something that we here at AWS can help you out with by working with a solution architect. They can help evaluate your data needs and talk to you about what makes sense there. Now, Dynamo is an incredibly popular service for us, first launched back in, I believe, 2012 now, so just celebrated its 10-year anniversary, used by companies in massive, massive scale, talking about millions of transactions per second, heavily used inside of Amazon, by Amazon.com and other teams as well. So very well kind of battled service that's been through a lot and seen a lot of scale and a lot of different use cases. Some of the most common ones that we see are what we'd consider hot data. So if you have data that exists inside your database that's just very rapidly accessed. Maybe you have a product catalog where 10% of the products are really the core of what your business is selling, and then the rest is a long tail. There's ways for architecting such that you would keep that hot data in Dynamo and have your relational database for then like the extent of your product catalog. There's other things like metadata or lookup tables or leaderboards or scoring boards, again, where a non-relational database makes a lot of sense because you're not doing a lot of complicated joins or where clauses where you're looking through wider scopes of information. So Dynamo could become a place where you start to move some of your workloads and start to scale. And again, with Dynamo, we don't get into much further than this, but a couple different scaling options. There's an on-demand option. You can do provision capacity. And so again, based on your needs, it can scale really pretty far. Now, when it comes to breaking up the backend here, the typical easiest thing to do is follow what you do with the data. So if you federate your database into federated clusters, you take your application and break it up to basically do a similar pattern. And so this is, again, where you might start to think about other compute options. Maybe you keep the core of your application running in App Runner. Maybe you start to build out certain APIs or certain services in Lambda. Maybe you have a reason for specific needs to look at other compute options. Maybe you need GPUs. Maybe you need other storage. And so this could be where you might need to look at potentially rolling some of the rest of the stack yourself. Maybe you need to go and use raw ECS containers and provision load balancers and do some of that. This might also be where you need to think about, again, when we talk about gluing together microservices, moving from synchronous to asynchronous. So one of the best tricks to scaling is to putting things like queues and SNS topics or Kinesis streams, or use something like EventBridge to put event buses between services. Gives you that ability to break up your application further. And this week at the application integration track, they've got some great content on all of that. And so we go from the diagram that we had here before with the databases and everything broken into it, into something that starts to look a little bit crazier as you go. And reality is that this might look something like this, where we've got combinations of API Gateway and Lambda, we've got ALBs and containers, we've got different databases, maybe we've got queues in the middle here. And so as you grow and scale and break apart your application, this becomes kind of what do we call it, the Netflix Death Star diagram of the thousands of services that we have. So again, this pattern becomes something that you start to just kind of stamp and break out over and over and over again with complexity that is typically pretty nuanced to your business and to your application. And it's really at this point that getting to this mythical 10 million users becomes pretty much achieved, right? We already knew that with the initial stack that we had, we could go really, really far. And then taking some very common steps, we have the ability to scale even further to meet the needs of what we're looking for. So what comes next? Well, again, it's basically taking what we've already discussed and iterating further on top of it. So more distribution of services. Some of our largest customers will have tens, if not hundreds of internal services. Really deeply analyzing your entire stack. So I'd encourage you to check out some of the talks in the observability track this week, talking about how to use X-Ray, how to use CloudWatch, how to use some of these deeper capabilities to really gain understanding of what's happening inside of your application, using tools like CodeGuru to understand where the most expensive application logic is that you have, both from a cost perspective, but also from a performance perspective. And then really thinking about where it is that it makes sense to utilize specialized resources. You could find that your application really requires a lot more memory per customer call than it does CPU. And so it might be, again, that the resources that App Runner has today don't best fit the workload that you have. But again, you don't want to start out with thinking about that. You might also need to think about how to add caching to a lot more of your application in different places. We talked about some of the basics here today. So, taking it further. With that, kind of in closing here, one of the things I think it's really exciting, and again, having built this deck originally 9 years ago and completely changing it for this year, is that when we look at the services that we have, and when we talk to the teams that build them and say to them, where do customers starting to run into pain points with these? Just out of the gate today, you get so much further with what these services can do with just basic initial configuration. And so you can actually feel really comfortable building MVPs, building new projects with an architecture like the one that we started out with, just those original 3 services, being able to see it go really, really far, again, potentially into tens of thousands of users, again, given a hypothetical situation. And again, the underlying resources, the compute infrastructure, AWS's global infrastructure just has more of whatever it used to have 9 years ago. More CPU, more memory, more storage capabilities, more network bandwidth throughput. And so again, being able to build high-speed performant applications, the bar is much, much lower than it's ever used to be. The bulk of scaling wins, again, come from doing less. Not from re-architecting, not from rebuilding. Again, when we talk about things like traditional SQL-based databases, you can get really, really far with a relational database these days on top of Aurora before you really start to run into the constraints that would force you off of that. Also, thinking about how to add caching, so caching at the edge, caching at the origin. That's one of the things that I commonly find companies missing early on that ends up really paying off in dividends very quickly. And lastly, being really cautious and thinking about how you refactor. Refactoring can be what we call sometimes a one-way door decision, right? If you do a refactor in a certain way, you could be buying into that path or that strategy for the foreseeable future before maybe another refactor necessitates rethinking it once again. So really thinking about how your data is shaped and how it's utilized and how it's read and viewed by your users and by your applications, and then kind of working backwards from there could be, again, a great technique for getting started. So with that, we hope that you've learned some new tips and tricks here this week, or in this talk, I should say. We thank you here for coming to join us. Apologies for some of the technical difficulties, but hope you have a great rest of your week. Hope you have some fun, and hope to see you soon. Thank you.